So what we'll do is, first let's try to understand the basic fundamental, that why do we need garbage collector? What is the use of garbage collector in .NET? Garbage collector is nothing but it's a feature provided by CLR, which helps us to clean unused managed objects. And by cleaning those unused managed objects, it basically reclaims the memory. So what happens is, when a .NET application runs, it can create several objects, and at a given moment of time, it's very much possible that, it will not use some of those objects, or it will not need some of those objects. So for those objects, basically, the garbage collector runs as a background thread continuously, and at specific interval, it checks, if there are any kind of unused managed objects, and if it finds any, right, it just goes and reclaims the memory. So garbage collector is nothing but it's a background thread, which runs continuously and basically checks, if there are any unused managed objects, and basically cleans those objects and reclaims the memory. Now remember that, garbage collector only cleans unused managed objects. It doesn't clean unmanaged objects. So in other words, anything which is outside the CLR boundary, the garbage collector doesn't know how to clean it. Right. Now, attached to garbage collector, and there is one more important concept called as generations. Okay, so there are three kinds of generation: generation 0, generation 1, and generation 2. Let's try to understand what is the concept of generations, and how does it affect garbage collector performance. So let's try to understand the concept of generation 0, 1, and 2. Okay, what exactly are these from the garbage collector perspective? Okay. Now let's say that you have a simple application called as app1. So this application has, let's say this is a Windows application, it recently started. Now as soon as the application started, it created, let's say, 5 objects. Okay. And now what happens is, as soon as application creates new objects or fresh objects, okay, these objects are moved into a bucket called as generation 0. So let's say that these 5 objects which are freshly created are first moved to the bucket, or it's categorized into a bucket called a generation 0. Okay. Now remember that all of these objects are managed objects. So in other words, if you have any kind of unmanaged objects like Excel component, or must be some VC++ or com component, right? It won't be the garbage collector fundamentals don't apply for them. Okay. So 5 managed objects are created, and as soon as they are created, they are pushed into a bucket called a generation 0. Now our hero, that is garbage collector, which is a background thread, and nobody knows when he will come and visit the application to see that which of the objects are unused. So let's say that the garbage collector comes once in a blue moon and says, okay, from these 5 objects, which are the objects which are not needed currently by the application. Now let's say that 2 objects are not needed by the application. Okay, so what it does is basically it goes ahead and basically removes or reclaims the memory of these 2 objects. Okay. Now the remaining 3 objects are yet needed. In other words, the application needs them. So what it means is, for this guy, for the garbage collector, what it means is that he cannot claim these memory. So what it does is he moves these objects to generation 2 bucket. So all these 3 objects are moved to the generation 1 bucket. I'm sorry. Okay. So now they are pushed ahead to the generation 1 bucket. Okay. Now let's say your application keeps on running. Okay. And it creates more fresh objects. So let's say that it creates more 2 fresh objects. Okay. Now the garbage collector again comes, must be, after some undeterministic period, it again comes and says, okay, let me see, which objects are now not needed. So it goes and checks for the generation 0 bucket, and now let's say that basically from this generation 0 bucket, both of these objects can be claimed. So it claims them and cleans them. Now it goes to the generation 1 bucket and says that you 3 guys, I had not claimed your memory. So are you still needed? Are you still needed in the application? And let's say one of the person says yes, like he is needed. Okay. And the other one says no, they are not needed. So what it does is the remaining 2, he actually goes and reclaims their memory. And the last one, the other one, which basically is still needed by the application, he moves that object to generation 2. Okay. So he removes them from generation 1 and he moves them to generation 2. Right. So in other words, generations are nothing but, they defined, how long the object is staying in the memory, or how long the object has been in the memory. Okay. Now you must be wondering that why do we need these generations? Okay, what is the concept of these generations? See, now what happens is normally when we talk about big applications, right, they can create thousands of objects or must be hundreds of objects. We do not know. Okay, and for each of these objects, if your garbage collector has to go and see them if they are needed or not, right, it's a pain. It's a pain, right, or it's a huge process, or it will be a bulky process. So by creating these buckets, right, what he means is that if an object is in generation 2, right, it means he will make less amount of visits over here, because when an object has moved to generation 2, that means it will stay more time in the memory. So there is no point going and asking them again and again, should I reclaim your memory or not. In the same way, generation 1 objects are more likely to be in the memory than generation 0. So he will more visit generation 0 bucket. Okay, so in other words, if there are 1000 objects, right, and if let's say 200 objects are in generation 1 and generation 2, then he will only go and browse the 800 objects, the remaining 800 objects. Okay, so in other words, generation 0, generation 1 and generation 2 help to increase the performance of garbage collector. Okay, so now that we have seen the concept of garbage collector and generation 0 and generation 1 and generation 2, let's try to visually see that how this generation looks like, or even is it possible to go and see the inner memory of garbage collector and see this generation with our naked eyes. So now in order to see the managed memory in .NET, right, there is a nice tool called as CLR Profiler. Now, in order to use CLR Profiler, what I've done is, basically I've created a simple Windows application here, you can see. And in this Windows application, what I'm doing is I've created a simple class here called as CLS1. This class really does not do anything as such, it's just a class here so that, we can just create some 1000 or 2000 objects. Okay, so just a simple class here. And then in the button click, what I'm doing is I'm just looping 1000 times and I'm creating objects. So let me build this application. And let's go to the CLR Profiler. Now, the CLR Profiler is nothing but it's a tool, which you can get from Microsoft.com. So if you just go to Microsoft.com and search for CLR Profiler, you will get, 2 downloads. Like one is for the 64-bit and one is for 86. So you can take whichever is appropriate for your environment. So let me go and run this profiler, and let me browse to the application and pick up my application here. So there goes my button. And let me go ahead and create the 1000 objects. So we'll go and create the 1000 objects, and let me just close this. Now, if you go to objects by addresses, right, you will see a nice visual graph here saying that the generation 0 objects. Okay, now that's right, because we have created 1000 objects, and all of those 1000 objects are basically in generation 0 at this moment. Okay, so in this way, you can view what are the different kind of generations, which are how many objects are allocated in which generations. And if you want to really see more view of your objects, so must be like this view. Okay, so you can go and basically adjust your readings accordingly to see a better view of it. Right. So by using the CLR Profiler, you can get an idea of that how many objects are created in generation 0, generation 1 and generation 2. Now the most important point here to remember is that more the objects in generation 0, the better it is. Why? Because what it means is that the objects are created and the memory is claimed. The more the objects are in generation 1 and generation 2, the worse it is. Why? Because that means that the memory is getting allocated, but it is never getting cleaned up, or it is never getting reclaimed. So until your .NET application runs, right, that memory cannot be claimed back. So a healthy application sign, at least for the managed memory, .NET managed memory, is that there should be the most of the objects should be created in generation 0 rather than generation 1 and generation 2. So I hope that you have enjoyed this video. In the coming video, we'll try to understand that how by writing destructors or finalize, right, how our objects are created more in generation 1, then how we can rectify it by using the finalize